Hi, I am Shalin Humbi, Assistant Professor in CSE Department from RMT Engineering College. Discussed about the topic is addressing modes of 8086. So, different types of addressing modes: immediate, register addressing, register indirect, index, based addressing, based and indexed with the displacement, string addressing mode. So, these all are the few addressing modes. 8086 supporting lot of addressing modes. First one is immediate addressing modes. The instruction will specify the name of the register which holds the data to be operated by the instruction. So here the source data is within the instruction. So here it is the instruction to move the data from one register to another register. 10AB. It is one of the four digits, that means 16-bit hexadecimal number. H represent as a hexadecimal number. So AX register is a 16-bit register. So 16-bit register. So 4 digits value we have to move from. This is the data. It's not a register. The value, directly the value move to the AX register. So here the second instruction, BF is a 8-bit register. So we have to save only 2 digits data. So these all are the data directly move to one register. The third instruction, add is one of the instructions. Some data means directly the value will be added to the AX value. AX one of the register, AX holding some data. That data is added with the 2929. Then finally, the result again saved inside the register AX. The second one is register addressing mode. So register is the source of an operand of an instruction. Source data is within the instruction. So here CX is one of the register. So CX having some value. That value move from CX register to AX register. So AX, CX, these all are the 16-bit register. AL is one of the 8-bit register. So BX register is a 16-bit register, can be divided into B lower order, B higher order. So AL 8-bit data, AL holding some 8-bit data, that data adding with the BL data. Finally, the answer will be saved inside the BL register. So here move is one of the instruction. So this CX having some data, that data is moving from CX to AX. So here add is one of the instruction. AL holding some data, BL holding some data. Adding of these two data, finally the answer will be saved inside the BL register. The third one is direct addressing mode. So memory address is supplied with the instruction. So memory address is not index or pointer register. So here this is an example. AX within the square bracket, some data is there. So first immediate addressing mode, without the square bracket, data is here. So that is data. So within the square bracket, some number is here, means it is called the address. So 1592, it is acting as an address. In this address, holding some data. That data only move to AX register. That is called a direct addressing mode. Within the square bracket mean it is not a data, it is an address. So in this address 1592, it is an address. In this 1592 address holding some data, that is operand, that data only move to the register AX. That is called a direct addressing mode. The fourth one is register indirect addressing mode. So register, it is almost similar to the direct addressing mode. So here within the square bracket, directly data is given. Here within a square bracket, one register is given. So here first register, BX holding some data. that data is acting as an address. Okay, that address holding some data. Again, for example, BX holding some data means, so 1592, that data only holding by the BX register. So again, within the square bracket means, so it is again acting as a register, sorry, acting as an address. So again, 1595, sorry, 1592. Initially, BX register having some data. That data is 1592. So 1592 here. 1592. BX holding some data. Here address is BX register. BX register some data. That data is 1592. So 1592 again acting as address. So here this data holding some value. Again move to the operand. So 1592 acting as the address. In this address, again having some data, that data it is called a operand. This operand moved to the AX register. It is called a register indirect addressing mode. So based addressing mode. So based addressing modes. So we have to add here last register indirect. Same. Up to this is a register indirect. It will be added to the 04. So it is one of the value directly data. In this data added with one register. So finally here BX having some data. This data is added with some number. So after that BX register means BX having some data 1592. So within a square bracket means this data, this address 1592 acting as address, address having some data. In this data added with the 04, finally we will get one number, that number within a square bracket, that is also acting as address, that address having some data, that data, for example 1592 holding some value, that is operand, that operand added with the 04, finally within a square bracket that value we will get, that is acting as an address, that address holding some data, that is operand, that operand only move to the register DX, that is called a based addressing mode. So the offset address of the operand is given by the sum of the content of BX or base pointer register and 8-bit or 16-bit. Base pointer means 16-bit. So BX means it is a 8-bit. Index addressing mode. So index addressing mode. So source index, destination index. Two index register supported by the 8086 architecture. So in this index having some data, in this register, okay, some data, that data SI index register holding some data that is acting as address, that data added with the 114, 14. It is one data, okay. So finally after the adding, we will get one number that is within the square bracket mean in this number acting as the address. So in this address holding some operand, that operand only move to the register DX. So the operand offset address is found by adding the content of source index or destination index register, 8-bit or 16-bit with the displacement value. So this 14, it is called a displacement value. Any data directly added with any one register, index register. So based index addressing mode. So see this previous example, one index register added with one displacement value. But here one register, one index register. So in this register holding some data, index register holding some data. So in this data added, finally we will get one address. That address holding some data, that operand only move to the CX register. Okay, so here base register, that number, here register, finally added, we will get one number, that number is acting as address, that address holding some operand or data, that data only move to the CX register. So the offset address of an operand that is computed by summing the base register to the content of the index register. The next one is based indexed with the displacement addressing mode. The operand offset address is computed by adding the base register and the content of the index register and a 8-bit or 16-bit displacement value. So here it is like a general purpose register, any one AX, PX, CX, DX. 4 general purpose register supported by 8086 architecture. So any one index register, source index or destination index with a displacement value. So these 3 will be added. So here it will be holding some data. It will be holding some data. It will be holding some data acting as address. That address having some data. That data is added with this data and with the displacement value. Finally, we will get one address. That address holding some operand value. That operand only move to the AX register. So here in this instruction is different. Here instruction is move. So that's why the data is moved to the AX register. So here addition means CX already having some data. So finally we will get one data from this. So after adding of these two, the output will be saved inside the CX register. The last string addressing mode. So what is the definition of the strings? A collection of data. Collection of characters, not a single character, more than one character. So the memory source address is a register, source index in the data segment, and memory destination is register DA, destination index in the extra segment, data segment and extra segment. So the data moved from source data segment to extra segment. Okay, so here source index data segment, destination index extra segment. So here one data, here also one data. So here this is the source index, here this is the destination index. The source index starting address is 5000 for example. The destination index, the starting address is for example 6000. So collection of strings means the data here more than one character. For example, the character is I, H, A, I. So initially first this 5000 holding the data is H. This H is moved to destination index. Again, we have to increase the address or decrease the address. If DF value is 0 means the source index will be adding 1. Increment the data. Destination index also increment. For example, the first address is 5000. The second address is 5001. So 5001 move to the 6001 position. And the next data is 5002. That data is moved to the 6001. So more than one character moved from data segment to extra segment. So here in case we have to save the data, 5000 data move to the 6000. Again, we have to reduce the decrement the address means we have to use this. If DF value is 1, the SI value and DI value is decrement. In this example is increment. If you want, you have to decrease the data. So that is depends on the value of DF equal to 0 and DF equal to 1. DF equal to 0 means segment index register value will be increment plus 1. If DF equal to 1, source index and destination index value decrement by 1. Okay, thank you.